In this video, we'll see how to design a Turing machine for odd length palindrome. Odd length palindrome. Okay. So L is equal to W C W power R. Okay. W in A comma B whole square. Okay. There is no this the length of this particular palindrome would be odd. In the previous example, we saw even length palindrome. Even length palindrome. Okay, here it is odd length palindrome. For example, I'm taking the input string A, B, A, B. This is a palindrome, right? A, B, A, B, A, A, B, A, B, A. But the length of this palindrome is what? 5, which is a odd number. So we saw only to design a Turing machine for even length. Now we'll see how to design it for odd length. There's no much difference. It's a very slight change to the previous Turing machine. Okay. So same logic. You find the tape would be A, B, A, B, A and blank space. So usually in Turing machine this would also be blank, but for now we do not need that. So that's why I'm starting from the string A. Here, so same logic. You find A, replace it with blank, move to the end, replace it with blank. Okay, if it is a different element, different symbol, then reject the string. And come back, replace this. Okay, come back, replace this with blank. So this is so in even number, this also will be matched with something else. Okay, in odd number, the only difference is in odd number in the center variable will not have another symbol to be matched with. So whatever it may be A or B, you just replace it with blank. So this is the slight change and this is the logic for odd length palindrome. Let's see how you can draw a state transition diagram. A, B, A, B, A. After this, it's called blank space. Let's see. Okay. So first state is Q naught. Same logic, right? If it is A, replace it with blank, move right. Q2. Okay. If then you move till you get a blank space and move one step left. In between, you will have any number of A's, don't do anything, keep moving right. In between, you will have any number of B's, don't do anything, keep moving right. Until you find a blank space. Now you found a blank space. So you move one step left. You replace this with blank. You keep moving until you find a blank. You found the blank space. Move one step left, and change that A to blank. So you're changing that A to a blank space. Okay, and move left. Change this to blank and I'm moving left. So here you change this A to Q3. Okay, so you are to keep moving until you find another blank space, right? Then only you will know the second left. Second left moves. In between, you will have any number of A's. Don't do anything. Just keep moving left. B's, any number of B's, keep moving left. Okay. Now you did for the A transition. Okay. Now you'll have to do for the B transition. Okay. If you find a B, change it to blank. Keep moving right. Q4. In between, you will have any number of A's and B's. Don't do anything. Then you will have a blank space. Replace that blank space. Okay, with the blank space. Don't do anything. Right. Okay. Then left. Q5. You have okay. Now you have found a blank space. Okay. In between, you had any number of A's and B's. You have ignored everything. Kept moving, and you found a blank space and one step left. Okay. Then you will have a B. Replace that with B replace that B with blank space and keep moving left until you find another blank space. Okay, so I'm just going to combine these two states, okay, and put it in the state. In the previous example, we had a two different states, right? So in the previous example, we had two different paths, one for A and one for B. But here we have a middle element, so we are combining these two paths here, okay? And you create an accept state. Final would be blank space, right? Here you have a blank space. We have created a separate path for those. But here we have a middle element. We combine till B and you create an accept state for both the blank spaces. If it is a blank, don't do anything. Just one step right and accept the string. Okay, so we are combining the states together because we have a middle element. Here we did not have a middle element. The even length and this is the odd length. So this is how you design a Turing machine for odd length